The song of a canary, bright and cheerful, and in days gone by, the sound of life itself to many workers. As long as the canary hopped around in its cage and sang its cheerful song, the work continued. But let the canary stop singing, and the work stopped. The bright yellow songbird was the first early warning device for unseen but deadly hazards, poisonous gases, or lack of oxygen. Advances in science and technology have both complicated and simplified our lives. Today, the amounts and types of airborne contaminants and poisons spewed into the workplace atmosphere are many times what they were even 50 years ago. New and potentially deadly chemical compounds and manufacturing byproducts, paint fumes, particles of pigment, dust, and smoke, all these things can sicken and even kill. So in today's workplace, there's a special emphasis on breathing safety, emphasis on air filters and respirators. Man, today's paints and finishes are a wonder. Properly applied, they'll stand up to just about any abuse for a lot of years. But the chemical compounds that make them so tough are potential killers. And they can be insidious, persistent as hell. The lungs are the most direct access to the bloodstream, but long or repeated exposure to skin can also be a major problem. The answer is a fully protective helmet-type respirator with an air hose attached and providing a constant supply of fresh, uncontaminated air. This type of supplied air respirator makes it possible to stay on the job as long as it takes, to work steadily and productively for long periods of time, and to protect the eyes and the skin from contamination. Welders working with copper or brass or some of the more exotic new metals have the same basic need for air supply respirators. The fumes generated by heat from a welder's torch are not just a nuisance on the job. They've proven to be long-term cripplers and killers. And since a welder has to be close to his work and for long periods of time, an air supply respirator is the answer. And an air supply respirator system only works if the air being supplied is fresh and completely free of contaminants. This system is provided with built-in filters to ensure against any contaminants being circulated back into the air supply. And this system pipes in completely fresh air from outside the paint shop. One or the other, or both, make the air supply respirator systems work. In situations where the exposure to contaminants isn't as long-term, or where the contaminants aren't considered as toxic, chemical cartridge respirators are often the answer. This is a modern variation of the military gas mask system. The wearer breathes air through chemical cartridge filters in the face mask, and the filters, usually activated charcoal impregnated with one or more additional compounds, clean the air. Another advantage is the respirator goes where the workers need it. Replace the filters regularly as recommended for the particular unit, and make sure the mask seals are getting the job done. If outside air is leaking into the mask due to improper seals or poor fit, then the job isn't getting done. And one more thing, don't ever wear this type of respirator in environments where contaminants don't have what's called adequate warning properties. That means a noticeable odor or taste or irritant to eyes or nose that will be recognizable as soon as the seal fails or a filter cartridge stops working. And if you're wearing a beard or a mustache, then this system's not for you. The facial hair will interfere with proper sealing of the mask. There are other systems for other purposes. For jobs of short duration in very hazardous environments, or for emergency uses, there are self-contained respirators with portable air supply attached, variations on the air packs used by fire departments and rescue squads. These units require special training and familiarization, and special care and maintenance. And on the other end of the spectrum are the simple particulate respirator devices. These filters are designed to block particulates like sawdust. Simple, cheap, easy to use with a minimum of experience, but no less important. Whatever the job calls for, simple dust mask or a constant stream of fresh air in a highly contaminated atmosphere, wear your respirator. Use it properly. Respirators should be regularly cleaned and disinfected, and always after each use. Respirators should be stored in a convenient, clean, and sanitary location. Worn or deteriorated parts must be replaced. A respirator is an important tool for safety. Use it. That way you can ensure that you'll be around to hear the birds singing. And a sweet sound it is. This is Claude Akins reminding you that safety is your... It's happening all over the country. People are using a new way to move up in business. Some workers are moving higher with no regard for anyone else. But as you'll find out in today's report, they may be riding for a fall. What devices are they using to get to the top? They call them by mysterious names like scissor lifts, aerial lifts, or sky lifts. Many people say they're even safer than ladders and quicker than setting up scaffolding. But the fact that they're so easy to use can create a false sense of security. When you work with a lift, the higher you go, the further you can fall. Today, our investigative reporters take an inside look at the dangers of moving up with potentially lethal lifts. The lift needs to be inspected and the controls tested each day before it's used. That way you can make sure everything is in proper working order. Even if the equipment is rented or leased, it is the responsibility of the user to inspect the equipment and to use it safely. There should be an inspection checklist in the manufacturer's operation manual. Only trained individuals should operate an aerial lift. Before lifting, make sure both the vehicle and the surrounding area are free of obstructions and other people. Choose a location for the lift where the boom will not contact any overhead wires or power lines. Many lift platforms are not insulated. Contact can result in electrocution and death. Find out how much voltage is running through any lines and follow all regulations for safe working distances. Before extending the boom, set the brakes on the wheels. Use wheel chocks if there's any chance the wheels could move. Assume all power lines are live. You should stay at least 10 feet from any power line up to 50 kilovolts, and even farther from lines with higher voltage. To avoid getting hurt, never remove, alter, or otherwise tamper with insulation or any other safety features on the equipment. You should only set up on a firm, level surface. If you set up on an incline, the center of gravity can shift as the boom goes up. That may send it crashing down. When you use outriggers, position them on pads or another solid surface. You should always check the controls before getting on a lift. Every lift is a critical lift, since every lift can put you in danger. Before a lift is raised, anyone on a platform must wear a body belt with a lanyard attached to the boom or basket. Never belt off to an adjacent pole, structure, or equipment while working in the basket. If the platform moves, you could be left hanging. You should never lean over platform rails to do work. Always stand firmly on the floor of the basket. Never stand on the side rails or a ladder in the basket or on anything else, such as boxes or planks. If you need to reach higher, even if only for a second, raise the platform. Only takes an instant for an accident to happen. Stay clear of pinch points and shear points when the equipment is in use. Remember, that when a basket on the platform moves, there is a possibility of getting pinched or crushed between the basket and any adjoining structure. Avoid climbing on extensible, articulating, or scissor arms. Be careful not to overload the basket. Keep your loads within the boom and basket load limits set by the manufacturer. You should never move an aerial lift truck while there are people elevated in the basket. When you're working with extendable boom and articulated boom platforms, which are designed as personnel carriers, you need to have both upper and lower controls. Lower controls must be able to override the upper ones in case of emergency. All controls must be clearly marked to show what they do. Unless there's an emergency, the lower controls should not be operated without permission of the operator in the basket. Anytime you move the basket, always look in the direction you are moving. Whenever someone is on the raised platform, there should be a ground safety operator in the immediate area. This person should watch for obstructions and hazards that may not be visible to the operator. Also, the person can take over from the platform operator if there is a loss of control. Our investigators found that if you want to move up in business, aerial lifts can give you a boost. But you got to use your head if you want to get ahead without risking your neck, because safety is your job too. This is Claude Akins reporting.
Using a ladder seems like a simple enough task, but using a ladder safely is not so simple. In the hands of a careless worker, a ladder can be a dangerous tool. Failure to take proper precautions can result in serious injury and even death. We use ladders so often that we sometimes forget how dangerous they can be. A ladder can slide, slip, tip, or break. It can also catapult a climber to his death. Ladders placed on uneven surfaces or ladders propped on top of another object to gain height are likely to move. If the rungs or the climber's shoes are covered with mud or other debris, the climber may slip and fall. The climber may also fall if he tries to climb while carrying tools or other objects, or if he overreaches from the ladder rather than moving it. The possibilities for accidents involving ladders are too numerous to mention, but one thing's for sure: most ladder accidents are caused by careless or improper use. Here are 5 steps you can take to help ensure safety whenever you use a ladder. First, choose the right ladder for the job. The ladder must be strong enough to support you and the tools or materials you plan to use. Portable ladders are rated according to load capacity. Always check the ratings and avoid exceeding the limits. Make sure the ladder is long enough to work from comfortably. If you plan to use the ladder to reach a roof or platform, keep in mind that the ladder must be long enough to extend 3 feet beyond the roof's edge or access point. This will ensure a good sense of support. If you're going to work around electrical current, choose a dry wood or non-conductive fiberglass ladder. A number of accidents occur each year because metal ladders contact power lines and equipment. Once you've selected the proper ladder, inspect it thoroughly. Look for loose or damaged rungs, steps, rails, or braces. Also check for loose screws, bolts, hinges, and other hardware. If the ladder shows any sign of disrepair, don't take chances. Take the ladder out of service and tag it as a warning to others. Your next step to ladder safety is particularly important. Set up the ladder with care. No matter how safe the ladder is, if it is placed in a dangerous location or set up improperly, an accident is bound to happen. When positioning a ladder, Use the 4-to-1 rule. That is, set the base 1 foot away from the wall for every 4 feet of ladder height. This ratio is important because if the angle is too steep, you might fall backwards. If the angle is too horizontal, the ladder can slip out from under you. Make sure the ladder has firm footing to keep it from slipping or falling. If the footing is not secure, lash the ladder to a secure object or have someone hold the ladder while you're on it. Make certain the side rails are resting against a solid structure. Never lean a ladder against an unstable or slick surface. When using a ladder to access high places, remember, make sure the side rails extend at least 3 feet beyond the access point. To ensure safety, tie off the ladder to keep it from slipping, or have someone support the base. Climb and descend ladders cautiously. To avoid slipping, check the rungs and the bottoms of your shoes for slippery substances. Wear shoes with slip-resistant soles. Face the ladder when moving up or down. Do not carry objects or loads that could cause loss of balance and falling. If you need tools, carry them in a tool belt or raise and lower them with a rope. Finally, use common sense when working on a ladder. Maintain 3 points of contact with the ladder: 2 feet, 1 hand, or 2 hands, 1 foot at all times. Avoid overreaching. Stretching and leaning to the side has resulted in countless falls. To ensure safety, keep your body centered between the rails. If you can't reach your work safely, move the ladder. Do not climb past a safe height. Climb no higher than the 3rd rung from the top on straight or extension ladders, or the 2nd from the top of step ladders. Every time you step on a ladder, you are betting your life on it. Remember the 5 rules of ladder safety. Choose the right ladder for the job. Inspect the ladder before you use it. Set up the ladder with care. Climb and descend ladders cautiously. And finally, use common sense when working on a ladder. This is Jim Bratton, reminding you that safety is the most important part of your day.
Scaffold accidents. They happen with startling frequency. Scaffold accidents do not have to happen. By knowing and following procedures for safe use, you can protect yourself and your coworkers from accidents that could be avoided. Scaffolds are used in construction for both interior and exterior work. They may be supported scaffolds or suspension scaffolds. A suspension scaffold means one or more platforms suspended by ropes or other non-rigid means from an overhead structure or structures. A supported scaffold means one or more platforms supported by outrigger beams, brackets, poles, legs, uprights, posts, frames, or similar rigid support. Today we're going to talk about supported scaffolds because these are the type used most frequently in construction. A key element in scaffold safety, whether it's a supported scaffold or a suspension scaffold, is platform weight capacity. In general, all scaffolds and scaffold components must be capable of supporting the weight of the structure and at least 4 times the maximum intended load applied. To ensure this integrity, it's important that scaffolds be designed by a qualified person and constructed and loaded according to design. Another element important to your safety and that of your coworkers is scaffold platform construction. Safety dictates that all working level platforms be fully planked or decked between the front uprights and the guardrail supports. If the platform is composed of several individual platform units, such as scaffold-grade planks, then the maximum space allowed between units or between a unit and an upright is 1 inch. However, if you can demonstrate that a wider space is necessary, for example, to fit around uprights when side brackets are used to extend the width of the platform, then an open space of up to 9 1/2 inches is allowed. Scaffold platforms and walkways must be at least 18 inches wide with certain exceptions. The maximum allowable space between the working edge of a platform and the face of the work surface is 14 inches, unless a guardrail system or personal fall arrest system is used to protect employees from falling. Exceptions apply to outrigger scaffolds and plastering and lathing operations. Each platform end must extend over its support by at least 6 inches unless it is cleated or otherwise restrained from movement by hooks or equivalent means. The end of each platform that is 10 feet or less in length must not extend over its support by more than 12 inches. The end of each platform that is more than 10 feet in length must not extend over its support by more than 18 inches. However, in both cases, the maximum extension distance over the support may be increased if the platform is designed and installed to support employees or has guardrails to block employees' access to the cantilevered end. On scaffolds where scaffold planks are abutted to create a long platform, each abutted end must rest on a separate support surface. On scaffolds where platforms are overlapped to create long platforms, the overlap must occur only over supports and shall not be less than 12 inches unless the platforms are nailed together or otherwise restrained to prevent movement. At all points of a scaffold where a platform changes direction, such as turning a corner, any platform on a bearer that rests at an angle other than a right angle must be laid first. Platforms that rest at a right angle over the same bearer must be laid second on top of the first platform. Besides meeting specifications for platform construction, supported scaffolds must also meet certain criteria to help ensure stability. Supported scaffolds with a height-to-base width ratio of more than 4:1 must be restrained from tipping by guying, tying, bracing, or equivalent means. Guys, ties, and braces must be installed at locations where horizontal members support both inner and outer legs. These must be installed according to the manufacturer's recommendations or at the closest horizontal member to the 4:1 height. These must be repeated vertically at locations of horizontal members every 20 feet or less thereafter for scaffolds 3 feet wide or less, and every 26 feet or less thereafter for scaffolds greater than 3 feet wide. Guys, ties, and braces must also be installed at each end of the scaffold and at horizontal intervals not to exceed 30 feet. Supported scaffold poles, legs, posts, frames, and uprights must be supported by base plates and, when needed, mud sills or other adequate firm foundation. In addition, footings must be level, sound, and rigid, and capable of supporting the loaded scaffold without settling or displacement. Also, supported poles, legs, posts, frames, and uprights must be plumb and braced to prevent swaying and displacement. Still another element important to your safety is the method of access to the scaffold. When scaffold platforms are more than 2 feet above or below the point of access, a suitable ladder, stair, tower, ramp, walkway, personnel hoist, or other suitable structure is required for access. Bracing may not be used as a means of access. If you're using hook-on or attachable ladders, they must be positioned so their bottom rung is not more than 24 inches above the scaffold supporting level. When hook-on or attachable ladders are used on a supported scaffold more than 35 feet high, they must have rest platforms at 35-foot intervals. Scaffold accidents do not have to happen. By making sure supported scaffolds meet requirements for design and construction, you can help ensure your own safety and that of your coworkers. Next time, we'll talk about safe work practices while using supported scaffolds. Scaffold safety begins with proper design and construction. To be safe, scaffolds must meet specifications designed to provide adequate support and help protect workers from fall hazards. Just as important, however, are procedures for safe use. It's essential that everyone who performs work on scaffolds knows these procedures and follows them carefully. Following safe work practices in any job is critical, but when working on scaffolds, it could be a matter of life or death. Today we're going to talk about some of the more important safe work practices that, if followed properly, will help ensure your safety while performing work on scaffolds. Before starting work, make sure you're familiar with the maximum intended load and load carrying capacities of the scaffold being used. Avoid loading scaffolds and scaffold components in excess of their maximum intended loads or rated capacities, whichever is less. Inspect scaffolds for visual defects prior to use. Safety regulations state that this inspection must be conducted by a competent person before every work shift and after any incident that may have affected the structural integrity. If that person finds any part that is damaged or weakened below the applicable strength provisions, the part must be immediately repaired, replaced, or removed from service. Make sure there is adequate clearance between scaffolds and power lines. Adequate clearance must also be allowed for any conductive material handled while working on scaffolds. For insulated lines, the minimum distances are 3 feet for voltage less than 300 volts, 10 feet for 300 volts to 50 kilovolts, and 10 feet plus 4/10 of an inch for each kilovolt over 50 kilovolts, or 2 times the length of the line insulator, but never less than 10 feet. For uninsulated lines, the minimum distances are 10 feet for voltage less than 50 kilovolts, and 10 feet plus 4/10 of an inch for each kilovolt over 50 kilovolts, or 2 times the length of the line insulator, but never less than 10 feet. Avoid erecting, moving, dismantling, or altering a scaffold unless you are directed to do so and supervised by a competent person qualified in scaffold erection, moving, dismantling, or alteration. Keep scaffold platforms clear of debris or slippery materials. Avoid using makeshift devices or items such as boxes or barrels to increase the working height of an employee. Also, avoid using ladders on scaffolds. Ladders are allowed on large area scaffolds only if special criteria for securing and stabilizing them are met. Avoid working during storms or high winds or on snow and ice-covered platforms unless the conditions have been determined by a competent person to be safe. Make sure you have adequate fall protection when working on upper levels of scaffolds. Guardrails or personal fall arrest systems are required when employees are working on a supported scaffold more than 10 feet above a lower level. The top edge height of guardrails must be between 36 and 45 inches above the platform surface. In the future, the top edge height of guardrails must be between 38 and 45 inches above the platform surface. Cross braces may be used as a substitute for either a top rail or a mid rail where specified criteria are followed, but not in lieu of an entire guardrail system and only on the intermediate levels. When working on scaffolds, take steps to protect yourself and your co-workers from falling objects. Always wear a hard hat when working on or in the vicinity of scaffolds. Where there is a danger of tools, material, or equipment falling from a scaffold and striking employees below, you must either install barricades to prohibit employees from entering the hazard areas, install tow boards, screens, or guardrail systems along the edges of platforms, or erect debris nets, catch platforms, or canopy structures to contain or deflect the falling objects. When potential falling objects are too large or heavy, place them away from the surface edge of platforms and secure them as necessary to prevent falling. Scaffold accidents do not have to happen. Before you perform work on any scaffold, make sure you know the hazards and understand the procedures to control or minimize those hazards. This is James Drury, reminding you to take care and be safe. Protective equipment. How many of us take it seriously? Data from the Bureau of Labor Statistics show that 84% of workers who sustained head injuries were not wearing hard hats at the time. 99% of workers suffering face injuries were not wearing face protection. 77% of workers with foot injuries were not wearing safety shoes or boots. 60% of workers with eye injuries were not wearing protective equipment. The majority of these workers were injured while performing their normal jobs at regular work sites. These statistics just go to show, if you're exposed to workplace hazards, you'd better take personal protective equipment seriously. Personal protective equipment includes all clothing or other work accessories designed to create a barrier against workplace hazards. Examples include hard hats, goggles, face shields, earplugs, steel-toed shoes, and respirators. There are as many types of personal protective equipment as there are workplace hazards. To be effective, personal protective equipment must be of the appropriate type for the hazard encountered. Take eye and face protection, for example. Eye and face injuries are caused by flying particles, molten metal, liquid chemicals, acids or caustic liquids, chemical gases or vapors, potentially injurious light radiation, or a combination of these. When selecting eyewear, goggles, goggles with side shields, goggles with face shields, choose the type that will best protect you against known hazards. Also make sure the eyewear fits properly. Eyewear that fits snugly and comfortably and offers the right protection in the right places will be there for you when you need it most. Now let's talk about head protection. Prevention of head injuries is an important factor in every safety program. Head injuries are caused by falling or flying objects or by bumping the head against a fixed object. Head protection in the form of protective hats must do two things: resist penetration and absorb the shock of a blow. To accomplish this, protective hats have a shell that is hard enough to resist the blow and a shock-absorbing lining composed of headband and crown straps to keep the shell away from the wearer's skull. Head protection is also available, which provides protection from electric shock and burn. If you plan to work around electrical hazards, select a hat that has been proof-tested for the voltage to which you will be exposed, such as a Class A or Class B hard hat. Now let's talk about protection for the arms and the hands. Examples of injuries to the arms and hands are burns, cuts, electrical shock, and absorption of chemicals. The most common type of protection against these injuries is gloves. However, no glove provides protection against all potential hand hazards, and commonly available glove materials provide only limited protection against many chemicals. Therefore, when selecting protective equipment for the hands, choose the most appropriate glove for a particular application. Also, know how long the glove can be worn and whether it can be reused. If you are in an occupation that requires special protection, make sure you use recommended protective devices. Electricians, for instance, may need insulated rubber gloves to protect against shocks and burns. Another part of the body that may need protection from workplace hazards is the foot. Hazards to the feet include falling or rolling objects, sharp objects, molten metal, hot surfaces, and wet, slippery surfaces. Again, when selecting protective footwear, select the device to fit the job. If you carry or handle heavy materials or tools which could be dropped, choose safety shoes or boots with impact protection. If you work around heavy pipes, paper rolls, or equipment which could potentially roll over your feet, wear safety shoes or boots with compression protection. If your feet are exposed to sharp objects, such as nails, wire, tacks, screws, large staples, or scrap metal, choose safety shoes or boots with puncture protection. Whatever footwear you select, make sure it fits comfortably. Many of us spend all day on our feet. If we take care of them, they'll take care of us. Still another form of personal protective equipment available is hearing protection. Exposure to high noise levels can cause hearing loss or impairment. It can also create physical and psychological stress. The best protection against occupational noise is earplugs or earmuffs. Selection criteria depend on the type of noise encountered and the auditory condition of the employee. If your company has a hearing conservation program, be sure to use recommended protective devices. Remember, there is no cure for noise-induced hearing loss. The only way to avoid hearing damage is prevention. When using personal protective equipment, any personal protective equipment, keep in mind that equipment alone does not eliminate the hazard. If the equipment fails, exposure will occur. To reduce the possibility of failure, make sure equipment fits properly and keep it in a clean and serviceable condition. Inspect personal protective equipment for defects before each use. If the equipment is defective in any way, avoid using it until it has been repaired or replaced. Personal protective equipment is designed to help protect you from workplace hazards. To enjoy the full benefit of personal protective equipment, know the hazards present in your workplace, know what type of equipment will best protect you from these hazards, know the limitations of that equipment, follow directions for use, and keep the equipment in good condition. Remember, to be effective, personal protective equipment must be used and used correctly. This is James Drury, reminding you to take care and be safe. Powered industrial trucks are important tools used in many workplaces. They perform a variety of material handling tasks and have made it possible to handle and transport heavy loads quicker and more efficiently than ever before. But like any tool, powered industrial trucks must be operated correctly. If they're not, they can be extremely dangerous to both people and property. Every year, powered industrial truck accidents cause approximately 100 fatalities and 36,340 serious injuries in general industry and construction. Most are the result of operator error. A powered industrial truck is a complex tool. To avoid accidents, operators must have the physical and mental ability to operate these machines safely. In this video, we're going to introduce you to the basic principles of powered industrial truck safety. These principles are very important. By learning and applying them, you can help ensure your safety when operating a powered industrial truck. The Occupational Safety and Health Administration defines a powered industrial truck as any mobile, power-propelled truck used to carry, push, pull, lift, stack, or tier materials. This includes forklift trucks, pallet trucks, motorized hand trucks, and rider trucks, among other vehicles. Powered industrial trucks differ in design, load capacity, and other features. Each type has its own unique characteristics, as well as some inherent hazards. As an operator, it's important for you to familiarize yourself with the type of vehicle you will be using. You need to know where the controls and instruments are located, what they do, and how they work. You also need to know the rated load capacity of the vehicle you're driving. This information can be found on the identification plate on the vehicle or in the manufacturer's manual. In addition, you must know how to inspect your vehicle. The physical and operational condition of a powered industrial truck can change from day to day and even from shift to shift. A pre-use inspection process can help you make sure that your vehicle is in safe operating condition. To avoid accidents when operating a powered industrial truck, it's important to understand how to operate the vehicle safely. Because a powered industrial truck is a motor vehicle, operating it is, in some ways, similar to operating a car. For example, powered industrial trucks have a steering wheel, a horn, and pedals for the brakes, clutch, and accelerator, and switches that control the lights and ignition. But even though these controls are similar to those of a car, how they are used to control the vehicle and its load can be very different. The first difference is steering. When you turn the steering wheel in a car, you steer the front wheels, and the car follows its front wheels into the turn. However, when you turn the steering wheel of a powered industrial truck, which has rear steering, you steer the rear wheels. The vehicle and its load must pivot around the front axle while being swung by the steering action of its rear wheels. Rear wheel steering allows you to turn more sharply, an advantage in narrow aisles. However, this can be a disadvantage because you can quickly encounter stability problems. Powered industrial trucks can tip with little warning, possibly resulting in serious injury or damage. Another difference between operating a car and a powered industrial truck is braking. Although both sets of brakes operate in the same way, the brakes of a powered industrial truck may not be as effective as those of a car. This is because powered industrial trucks are heavy for their size. Just like driving a car, driving a powered industrial truck too fast can result in losing control of the vehicle, causing it to skid, tip over, or fall off a loading dock or other elevated surface. Failure to maintain control of the powered industrial truck can also cause the vehicle to strike an employee or stored materials, causing the material to topple and possibly injure someone. Safe operation of a powered industrial truck depends not only on understanding the vehicle, but also on understanding the operating environment. Workplace features such as surface conditions, aisle width, visibility, and the presence of pedestrian traffic can affect how this vehicle will be operated. Operators of powered industrial trucks must know precautions to take when operating on ramps and grades, when driving onto trailers, rail cars or trucks, or when operating in hazardous locations such as closed environments. In addition, operators must take specific safety steps when handling and manipulating loads. Carrying unbalanced loads or lifting loads improperly, for example, can affect the stability of the vehicle and cause it to tip over. To help ensure safety, operators of powered industrial trucks need to drive safely at all times. They must observe all traffic regulations, including authorized plant speed limits, and regulations that apply to intersections and other locations where vision is obstructed. Stunt driving and horseplay are never permitted. Powered industrial trucks are powerful but dangerous tools. As the operator, you are responsible for the safe operation of your vehicle. This means that you need to know how to inspect the powered industrial truck, how to operate it safely in the workplace, and how to avoid injury and property damage at all times. Accidents involving powered industrial trucks happen every day, but they don't have to happen to you. This is James Drury, reminding you to take care and be safe.
Recently, sexual harassment has become a much talked about topic. The Senate hearings to confirm Judge Clarence Thomas prompted more questions than answers. What is sexual harassment? Would you know it if you saw it? Would you know it if you did it? As more women enter the workplace, concerns about harassment are on the rise. But it doesn't always happen the way you may think. First of all, you should know that your employer does not condone or tolerate sexual harassment of any kind. It can be offensive and could be illegal. There is no room for it in the workplace. Officially, sexual harassment is a form of sex discrimination that violates Title VII of the Civil Rights Act of 1964. The Equal Employment Opportunity Commission defines sexual harassment as any unwelcome sexual advances, requests for sexual favors, or other verbal or physical conduct of a sexual nature where submission is linked to employment decisions, or if the conduct unreasonably interferes with an individual's work performance or creates an intimidating, hostile, or offensive working environment. Legally, there are two kinds of sexual harassment. The first is unwelcome verbal or physical conduct of a sexual nature, used as an outright or implied basis for one's employment or advancement. In other words, requests or demands for sexual favors are clearly illegal. There's no question about it. The conduct may come from anyone, a boss, a supervisor, a coworker, even a customer. The gender of the harasser or the victim doesn't matter. It can be a female supervisor making unwanted sexual advances toward a male subordinate. If submission is a condition of employment, that's harassment. It doesn't even need to be a member of the opposite sex. If the conduct is thought to be sexual and the pressure is such that advances are unwanted, there's a problem. It's not just ill-advised, it's illegal. The second kind of harassment refers to a hostile or intimidating work environment created by sexual jokes, teasing, or comments, or even the presence of suggestive postures. This is where you have to be careful. Behavior that may be considered good-natured kidding by one person can be seen as harassment by another. What matters, though, is that one person has been offended by another person's behavior, and that in itself may be grounds for a complaint. When an incident does occur, the victim has several options for recourse. One, the victim may want to confront the harasser and let the person know that the conduct is unwelcome and must stop. What if the behavior continues? Or what if the victim doesn't feel comfortable confronting the harasser? Your company may have a procedure set up for reporting sexual harassment complaints. Many companies now have strict policies against harassment, and your company may have set up a formal grievance process to handle complaints. When a complaint is made, the company has a responsibility to take immediate and appropriate corrective action. The best way to handle sexual harassment in the workplace is to prevent it from happening. You need to know that sexual favors should never be a condition of employment, but we also need to be aware of how our behavior is received by coworkers. Remember that one key test of whether conduct is considered harassment is whether the behavior is unwanted. Ask yourself if what you're doing could be considered intimidating or offensive. Put yourself in someone else's shoes and consider their feelings. Language or behavior that seemed all right when the workplace was an all-male bastion can be intimidating in mixed company. What seems playful to you may seem offensive to someone else. Remember that these policies are for your protection and the protection of your fellow employees. Let's all do our part to establish and maintain a comfortable and professional working environment for everyone's sake. This is Claude Akins reminding you that ensuring a professional work environment is your job too.
Power tools. Their uses are many, but so are their hazards. There are risks from moving parts, as well as risks from flying debris. Injuries include cut hands and arms, severed fingers, electrical shock, blindness, and even death. The list of possible machinery-related injuries is as long as it is horrifying. A tool is only as safe as the person who uses it. You alone control the risk factor. For that reason, you should never use any power tool or machinery unless you've learned the hazards of the machine and the safe method of operation. Today, we're going to introduce you to training guidelines that, if followed properly, will help ensure your safety when operating power tools, whether at home or on the job. First, learn the machine's applications and limitations, as well as the specific potential hazards peculiar to this machine. Follow available operating instructions and safety rules carefully. It's critical to know the tool, especially if you're using it for the first time. The novice operator's accident is usually caused by a lack of knowledge of proper safety procedures. The novice cannot anticipate a potential hazard or identify an accident-producing situation. Read and reread the owner's manual that is supplied with the equipment. Get to know the tool, how it functions, what it can do, how to use it, and what its limits are. However, be aware that expertise can breed overconfidence. The experienced operator's accident is usually caused by either carelessness or an outright violation of the safety rules. Learn these safety rules and follow them carefully. For example, make sure all machine guards are in place and in proper working order. Never try to modify or remove machine guards. They are there for your protection. Be alert for electrical hazards. Always inspect power cords and extension cords before and after each use. If the cord is worn or damaged, replace it. Make sure the equipment is properly grounded. Tools should be either double insulated or have a 3-wire cord and be grounded. Ground fault circuit interrupters may be required at certain work sites. These devices minimize shock hazards by quickly shutting off power when electrical faults occur. Keep the working area clean and be sure adequate lighting is available. A safe, well-organized job setup is the key to good work. It ensures that you can handle your tools and materials comfortably and properly and work with care and precision. A dirty work area can contribute to accidents. Sawdust, shavings, paper, and rags can create a fire hazard and damage tools. A dirty or cluttered work area also provides slipping or tripping hazards. Wood chips or sawdust can create slipping hazards on certain types of floors. Keep floors and machines clear of scrap and sawdust, and clean up any scrap or liquids on the floor before someone falls or trips. Make sure the work area is well lit. Shadows and dim lighting contribute to operator fatigue and measurement errors. You should have a bright overhead light in your work area, and for precision tasks, direct focused light on your workpiece and tools. Do not wear loose clothing, gloves, bracelets, necklaces, or ornaments. Wear face, eye, ear, respiratory, and body protection devices, as indicated for the operation or environment. Dress for safety. Remember, rotating blades, cutters, and shafts on machinery can present hazards. A loose shirt sleeve can become wound into any rotating object and pull you toward it. Jewelry, such as bracelets and rings, can catch on machine parts or stock and lead to serious injury. Even long hair may become entangled in a machine. Tie back loose hair or restrain it under a cap. Wear the appropriate safety gear for the job. A shop has dust, flying wood chips, metal shavings, noise, rotating shafts, sharp cutting tools, and rough stock. All hazards that can injure or harm you if you do not protect yourself. For work that creates flying debris or when there is a risk of a chemical splash, wear safety goggles and, if necessary, also a face shield. Make sure safety goggles or face shields meet American National Standards Institute specifications. With dust creating cutting, grinding, drilling, or sanding tools or chemicals that emit hazardous vapors, use respiratory protection. Make sure respiratory protection devices are approved by the National Institute of Occupational Health or the Mine Safety and Health Administration. For work with noisy power tools, use hearing protection, earmuffs, or earplugs. Look for a device with a noise reduction rating of at least 25, which reduces noise entering the ears by at least 25 decibels. To handle sharp, rough, dirty, or hazardous materials, wear gloves. However, remove gloves before operating machinery, as your hand could be pulled into the blade if the blade catches the glove. Wear hard hats to protect your head from the danger of falling or flying materials. Also, it's a good idea to wear safety shoes or boots to shield your feet against injury when handling heavy stock which might drop. Whatever safety gear you select, make sure it is appropriate for the particular hazard and maintained in good condition. Broken safety goggles, for instance, won't help if a piece of scrap comes flying in your direction. Maintain tools after each use. Keep them clean, oiled, and in good condition. Store tools in a safe, dry place. Never use damaged or defective tools or accessories. When using pneumatic power tools, make sure a tool retainer is installed on equipment when necessary to prevent ejection of the tool. Also, make sure the tool is secured to the hose or whip to prevent the tool from becoming accidentally disconnected. Power tools. Their uses are many, but so are their hazards. You and only you control the risk factors. Before you use any power tool, become familiar with its operating procedures. Make sure you know how to operate the tool correctly and safely. Be alert for electrical hazards. Keep your work area clean and well lit. Dress for safety. Avoid wearing loose clothing or jewelry that could be caught in machinery. And always wear the appropriate safety gear recommended for the job. Maintain tools after each use. Never use damaged or defective tools or accessories. Remember, a tool is only as safe as the person who uses it. By following these safety tips, you will have a head start on the road to using power tools safely. This is James Drury, reminding you to take care and be safe. Table saws. Their uses are many, but so are their hazards. If you use table saws incorrectly, you risk injuries including cut hands and arms, severed fingers, electrical shock, blindness, and even death. Today we're going to introduce you to training guidelines that focus on the operation and use of table saws. By following these guidelines, you will help ensure your safety when using table saws, whether at home or on the job. A tool is only as safe as the worker who uses it. When you use a tool, you alone control the risk factor. When using a table saw or any power tool, start by making sure your work environment is safe. Set the saw at a comfortable height. Most operators prefer a height of 34 to 36 inches. Be sure the saw does not rock and has been leveled properly. When possible, it is good practice to anchor the saw to the floor. Be sure a grounded outlet of the correct amperage is close by. This outlet should be below the saw so the cord does not interfere with stock being cut. Adequate lighting makes operation of the saw much safer. Shadows and dim lighting increase operator fatigue and measurement errors. The area surrounding the saw should be ample enough to handle large pieces of stock. Traffic should be routed away from the back of the saw. Keep the floor around the saw free of cutoffs and debris, which could cause a slipping or tripping hazard. When using a table saw, wear appropriate personal protective equipment. Always wear protective glasses when you operate the table saw. If the area is noisy, wear earplugs or muffs to preserve your hearing and minimize fatigue. Gloves are all right for handling rough lumber, but never wear gloves when operating the table saw. Your hand could easily be pulled into the blade if the blade catches the glove or other loose clothing. When using a fine-tooth blade, wear a dust mask to protect your lungs. Know your saw. Make sure you understand its uses and its limitations. All tools have limitations, and using tools safely means recognizing and respecting those limitations. Never use a cutting tool larger or heavier than the machine is designed to accommodate, or operate a cutting tool at greater speed than recommended. When choosing blades, make sure the RPM rating of the blade is equal to or higher than the RPM rating of the saw, usually marked on its nameplate. Do not use a dull, gummy, bent, or cracked cutting tool. Keep tools sharp and clean for best and safest performance. Using a dull blade increases the chance of kickback or climbing. Dull blades also require more cutting force, which could throw the operator off balance. Remove dull, badly set, or improperly filed blades from service. If gum has adhered to the sides of the blade, clean the blade immediately. Use only accessories designed for the machine. Accessories can make machines more versatile, safer, and easier to use. However, the use of improper accessories may cause hazards. Consult the owner's manual for recommended accessories. Inspect your stock. Before sawing any stock, inspect it for nails, staples, knots, and severe warps. Loose knots can be ejected by the saw blade. Rough, warped, or wet lumber can cause kickbacks. Small pieces can also mean trouble. Machining them puts your hands too close to the blade. Make sure the stock is large enough to be machined safely. Adjust the machine for minimum exposure of the cutting tool necessary to perform the operation. Adjust the blade height to keep the blade low. Set the blade height no more than 1/4 of an inch above the stock being cut. This minimizes your chances of contact with the blade and reduces kickback hazards. Before turning power on, remove tools and debris from the work surface. These could be violently thrown from the machine on startup, causing serious injury to the operator or a nearby worker. Be positive that anti-kickback devices are positioned properly. A kickback occurs when a piece of stock is forced toward the operator at great speed. Kickback is a major cause of table saw accidents. By using a guard with a spreader and anti-kickback pawls, you minimize the chance of kickbacks. When making rip cuts, adjust the spreader so that it is on the same plane with the blade. Most manuals recommend that you align the spreader with the blade by sight. Make sure that the anti-kickback pawls are riding on the wood. Keep in mind that spreaders can become loose during operation. Always check the spreader to be sure it is locked securely in place. Also, check the position of spreaders and pawls whenever you adjust the guard or blade height, or whenever changing blades. Position yourself correctly. Stand to the side of your work to be clear of any stock that kicks back. Be sure you have firm footing and balance. Avoid overreaching and reaching over the blade. Keep hands well away from saw blades and other cutting tools. Keep your hands at least 6 inches from the blade to allow for error. When your hands are a safe distance from the blade, there is always time to react to a hazardous situation. Use push sticks to feed stock into a bit or blade. By using push sticks, you keep your hands well away from the blade. In a safe position, yet you still maintain complete control of the stock. Guard against accidental starting. When making adjustments to the table saw, do so with the power off. Unplug the machine or lock the disconnect switch in the off position. When servicing a machine, isolate it from its energy source and follow lockout, tagout procedures. Notify all affected employees that the machine must be shut down. Table saws have many uses, but they also have many hazards. By learning and following the recommended training guidelines, you will help ensure your safety when operating table saws. This is James Drury, reminding you to take care and be safe. Flames and sparks to worry about, arc rays, flying debris, and even electric shock. But there's another hazard that may not be so obvious. That's the hazard associated with handling the cylinders that contain compressed fuel gases. These cylinders, sometimes called sleeping giants, have great destructive power. If mishandled, they can explode, leaving a wide swath of death and destruction. Gas cylinders used in welding, cutting, and brazing operations contain potentially dangerous gases. These gases include oxygen, which supports combustion, and propane or acetylene, which can be explosive when mixed with air or certain compounds. There's only one way to avoid trouble when handling gas welding cylinders, and that's to observe safe work practices at all times. First of all, inspect all cylinders for damage, corrosion, or other signs of possible damage or defects before using. If you see any damage or defects, take the cylinder out of service. Handle cylinders carefully. Remember, these cylinders contain potentially dangerous gases under high pressure. Avoid dropping cylinders or allowing them to strike each other violently. Also, be careful to keep oxygen cylinders and fittings away from oily or greasy substances. Oil and grease may ignite spontaneously when in contact with oxygen. When using fuel gas cylinders, place them valve end up. Make sure they are secured and on a flat surface. Keep cylinders away from sparks, hot slag, or other sources of artificial heat. Also, keep cylinders away from contact with electric circuits and from possible grounds for electric circuits. Never tap electrodes against cylinders to strike an arc. Always take precautions when opening cylinder valves. Before connecting a regulator to a cylinder valve, open the valve slightly, then close it immediately to clear the valve of dust and dirt. Always stand to one side of the outlet when opening the cylinder valve. Do not crack the valve of a fuel gas cylinder near other welding, sparks, flames, or other sources of ignition. Open valves slowly to avoid damage to the regulator. For quick closing, do not open the valve on a fuel gas cylinder more than 1 1/2 turns, and preferably no more than 3/4 of a turn. Avoid placing anything on top of acetylene cylinders that might damage the safety devices or interfere with the quick closing of the valve. Also, avoid tampering with safety devices in cylinders and valves. Before using gas welding cylinders, make sure all hose, cylinder, and regulator attachments are tight and not leaking. If you find a leaking valve or fitting that can't be stopped by closing the valve, take the cylinder outdoors, away from sources of ignition, and empty it slowly. If the fuse plug or any other safety device develops a leak, remove it from the work area. Post warnings to keep lighted cigarettes or other sources of ignition away. Also, tag the cylinder and notify your supervisor. When you're finished with the job, close all valves, even if the cylinder is empty. Remove regulators and replace protective caps before transporting cylinders. Store cylinders only in designated storage areas. Store oxygen cylinders away from acetylene or other fuels. In a fire, the oxygen would support and greatly accelerate combustion of flammable materials. Store acetylene in a separate fuel compound. Secure cylinders in a vertical position, never on their sides. Storing or using acetylene in any other position can be extremely dangerous. When used properly, gas cylinders are safe, but when used improperly, they have the potential to do great harm. To ensure safety, know the hazards and take appropriate precautions. This is James Drury, reminding you to take care and be safe. Ever since the Iron Age, mankind has considered metal precious. It is strong, resilient, sturdy, ideal for the tools we need. But for metal to serve our purposes, we must apply tremendous energy to transform it into things we can use. It's up to you to keep this energy under control. Welding and cutting operations harness this energy to modify these metals. Before using any welding equipment, make sure cables are not worn to the extent of exposing bare conductors. Cables with splices or repairs within 10 feet of the electrode holder should never be used. Report any faulty or defective equipment to your supervisor. Avoid coiling or looping the electrode cable around parts of your body. If you need to work in a permit-required confined space, you must follow specific precautions. Make sure you're completely familiar with those precautions and are in full compliance before you start any work. Proper ventilation is required for any confined space work. When cutting or welding in confined spaces, the gas cylinders or welding machines must be left on the outside. Anytime you leave a welding operation for more than a few minutes, such as for a lunch break, you need to eliminate the possibility of accidents. All electrodes need to be removed from the holders and located so they won't make accidental contact. Remove all leads and torches from a confined space. When arc welding, disconnect the machine from the power source. Never dip hot electrode holders into water, because that could expose you to electric shock. When gas welding, torch valves need to be closed and the gas supply positively cut off outside any confined areas. It's also a good idea to remove the torch and hose from any confined area. You need to use the proper protective gear anytime you're cutting or welding. To protect your eyes, helmets or hand shields are required during all arc welding or arc cutting operations, except underwater. You need suitable goggles during gas welding or oxygen cutting operations. Of course, you need to wear protective clothing that is suitable for the type of project you're working on. Helpers or attendants also need proper eye protection. Other workers nearby need to be protected by screens. Otherwise, they are required to wear appropriate goggles. In addition to the general rules, there are some regulations that apply specifically to acetylene welding or cutting. Everyone who uses fuel gas, such as acetylene, needs to be trained in how to use it safely. Acetylene is very unstable at high pressures. That's why it should never be generated, piped, or used at pressures greater than 15 psig. The only reason acetylene can be safely stored under higher pressures in cylinders is because it is dissolved in acetone. That's why it is crucial that you only open valves on acetylene tanks when they are upright. Otherwise, the acetone may leak out and create a hazardous situation. If you are going to be using torches that have shut-off valves, they should not be connected directly to the cylinder. You need to first reduce the pressure by installing a suitable regulator attached to the cylinder valve or manifold. Before you connect a regulator to a cylinder valve, you need to crack the valve to clear it. Before cracking a valve, make sure it's not possible for the gas to create a flammable atmosphere or to reach a nearby source of ignition. Nearby welding work, sparks, or flame could set off the gas. Open the valve slightly and close it immediately. Cracking the valve like that clears the dust and dirt out of the valve so it won't get into the regulator. Be sure to crack the valves on both the fuel gas cylinder and the oxygen cylinder. When you're cracking a valve, stand to one side so it won't be aimed at you or anyone else. Once the regulator is attached, you should always open the valve slowly so it doesn't damage the regulator. It's very important that valves can be closed quickly if there's an emergency. That's why valves on fuel gas cylinders should never be open more than 1 1/2 turns. However, the valves on oxygen cylinders should always be open all the way. Excessive pressure can corrode the valve or valve seat so it will not close properly. If you need to use a special wrench or other device on the stem of the valve, always keep it in place while using the cylinder so fuel can be shut off quickly in an emergency. You should never put anything on top of fuel gas cylinders that might damage the safety device or keep you from closing the valve quickly. Before removing a regulator from a cylinder valve, you always need to be sure that the valve is closed and the gas is released from the regulator. Again, make sure there are no sources of ignition nearby. If you find a leak around the valve stem when you open the valve on a fuel cylinder, close the valve and tighten the gland nut. If that doesn't fix the leak, stop using the tank right away. Tag it and put it in a safe place to be checked immediately. When you are doing welding and cutting, you are reshaping our world. But the same energy that can create can also destroy. That energy is in your hands. It's up to you to control it and use it wisely. This is James Drury, reminding you to take care and be safe. How would you escape from your workplace in an emergency? Do you know where all the exits are? Are you sure the doors will be unlocked and that exit access will not be blocked during a fire, explosion, or other crisis? Knowing the answers to these questions could keep you safe during an emergency. An emergency action plan is a plan required by OSHA that describes the actions employees should take to ensure their safety if a fire or other emergency occurs. Well-developed emergency plans and proper employee training can help save lives and reduce property damage. As an employee, it is part of your job to understand your roles and responsibilities as defined in the Emergency Action Plan. First of all, the Emergency Action Plan describes procedures for reporting a fire or other emergency. Common methods include dialing 911 or an internal emergency number or pulling a manual fire alarm. Whatever system your company uses, make sure you know how to report an emergency, any emergency. If your company relies on outside assistance such as fire, medical, or rescue services, know how to contact these authorities if necessary. Also, make sure you're familiar with the alarm system used by your company to notify employees to evacuate and/or take other actions. It is recommended that alarms used for different actions be distinctive and include horn blasts, sirens, or even public address systems. The second element of an emergency action plan is a description of procedures for emergency evacuation. The evacuation policy includes information on the type of evacuation as well as exit route assignments. Many employers create maps from floor diagrams to designate escape routes to be followed by employees. Evacuation policies often describe actions employees should take before and while evacuating, such as shutting windows, turning off equipment, and closing doors behind them. Also, depending on the type of emergency, your plan may designate assembly areas or areas where employees will gather following an evacuation, both inside and outside your workplace. Assembly locations within the building are often referred to as areas of refuge. Make sure you understand your role and responsibilities in an emergency evacuation. Know where all exits are located and which exit accesses, such as hallways, will be open during a fire, explosion, or other emergency. Also, make sure you know where to report following an evacuation. This knowledge could be critical to your safety. The third element of an emergency action plan describes procedures for employees who remain on site after the alarm sounds, if necessary, before evacuating. Employees may be required to operate fire extinguishers or shut down gas and/or electrical systems and other special equipment that could be damaged if left operating, or create additional hazards to emergency responders, such as releasing hazardous materials. If any employees will stay behind, the emergency action plan must describe in detail the procedures to be followed. All employees remaining behind must be capable of recognizing when to abandon the operation or task and evacuate before their egress path is blocked. The fourth element of an emergency action plan describes procedures to account for all employees after the evacuation to ensure that everyone escaped. This might include procedures for designated employees to sweep areas, checking offices and restrooms. The plan may also include procedures for conducting a roll call in an assembly area. Many employers designate an evacuation warden to assist others in an evacuation and to account for personnel. The fifth element of the emergency action plan describes procedures to be followed by employees performing rescue or medical duties. Most small organizations rely on local public resources such as the local fire department or hospital to provide these services. Larger companies may have their own emergency and rescue services. These individuals must be trained and equipped to perform their duties. Untrained individuals may injure themselves while trying to rescue. For this reason, it's safest to leave the rescue work to those who are trained, equipped, and certified to do so. In addition to the key elements just discussed, emergency action plans include the names, titles, departments, and phone numbers of employees who can be contacted for additional information or clarification of some aspect of the plan. Also, emergency action plans include a description of how employees will be informed of the contents of the plan and trained in their roles and responsibilities. Before implementing an emergency action plan, employers must designate and train enough people to assist in the safe and orderly emergency evacuation of employees. Training should be offered when the plan is developed or the employee is assigned initially to a job, when the employee's responsibilities under the plan change, and when the plan is changed. Emergencies and disasters can strike anyone, anytime, anywhere. You and your coworkers could be forced to evacuate your workplace when you least expect it. Remember, preparedness is essential to safety. Know how to escape from your workplace before an emergency occurs. This knowledge could save your life. This is James Drury, reminding you to take care and be safe.